Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Get started here. Thanks for joining our Mobile Industrial Robots Software Advancements webinar. Got myself here. I'm Kyle Wiggert. I'm a controls engineer and MiR application specialist and integration specialist for Hartfiel Automation. I've been with Hartfiel for about 1.5 years now, and MiR has been my main focus since starting here at Hartfiel. I also have my cohort on here with me today, Liam from MiR. Liam, would you like to introduce yourself?
Sure, thanks, Kyle. So my name is Liam Ngoven. I am the area sales manager for Mobile Industrial Robots in the Western U.S. I've been with MiR a little over 3 years now, and in my current role, I'm working with our partner network and end customers in the Western U.S.
Awesome. Thanks, Liam. So today we'll go through some introduction stuff, and then we'll go into the version 3 upgrade, and then Liam will tag along on the insights portion of the MiR, and then we'll jump into a short Q&A. So with this version 3 upgrade, we'll go through some of the performance improvements, upgrade processes, and risks. So here's the user interface portion. This has been heavily updated in version 3. There's several tools now at your disposal when utilizing the map editor. A new one that I find I often use is the function for finding positions and searching through those positions. So sometimes when you make a position, you might lose it. But now that you can search those, it's much easier to find them. And if you have multiple positions of similar names and you're just using numbers to follow that, you can click through those and find those using that search function. So you can, like I said, you can find those positions, and then you can also see a list of all the markers and the positions on that map. Now there are also some filters as well, so you can filter the map as well. This is very beneficial for editing the maps when you have multiple overlapping layers. So filtering those layers that you don't need out so you can focus on the ones that you do need makes those edits much easier. There's also been some changes in the groups on MiR Fleet. There's now a separate page for organizing charging groups, robot groups, and staging groups. So when the robots it makes the robots easily identifiable to which group they're in. That way you can pick and choose which robots you want to complete which missions, as well as organize them accordingly. So some of the performance included on version 3, the new navigation system improves the speed and robustness of the planner and the footprint switching. It also includes a new map zone and a revision of several of the planner system settings. So some of those system settings include the planner on the global path. So previously the robot would only plan a new global path when an obstacle would block the original global path in a way that the local planner couldn't plan around it. So now the robot instead calculates new potential global paths whenever the robot's driving to a goal position, and then updates that path if it finds a shorter route at any point along that path. This allows the robot to plan a new path when encountering an obstacle as it detects them, instead of driving to that obstacle and then needing to plan a local path. If that local path is too long, it can immediately plan a global path around that obstacle. So another setting that has changed as well is the blocked path timeout. So the blocked path timeout replaces the retries parameter and is now an adjustable time versus a set number of retries with a non-adjustable time of 5 seconds in between retries. So you can set that accordingly to, instead of setting retries and retrying every 5 seconds, you can retry a set number of times in your mission, and then you can set that time as well. The next one would be resource lock customization. This allows for the customization of the distance when the robot will take over a resource. So previously this was a set distance of 10 meters, but now this can be adjusted to avoid deadlocks in smaller areas, such as elevator hallways or local cart positions where you have multiple items in one area. Another settings change has been the access zones and directional zones. So access zones have replaced critical zones. We've done away with critical zones and now use these access zones. So these are relevant for obstacles that will disappear as the robot gets closer, such as automatic doors, ramps, and even elevator doors. So you'll want to, if you do upgrade, you'll want to ensure that those critical zones are replaced with access zones wherever you need them. And they do function a little differently, so you might not need critical zones where you previously had critical zones due to the updating of the planner. So in tandem with that, the directional zones have also changed a little bit as well. So there's now a setting to allow the robot to drive against directional zones while replanning. By default, this setting is disabled, meaning the robot will never drive against directional zones. So you can change that accordingly if you would like to drive against the directional zone for a short period of time in a replan. So in some of the robot system improvements, there's been some Wi-Fi improvements. The robot can now automatically roam between access points from all enabled networks. So only one SSID at a time, but you are able to roam from network to network as you move throughout the building if that's something you would benefit from. However, this is only to be used on a case-by-case basis, as MiR still recommends having one dedicated network and only one net. And so with that one SSID, you can only have one network connected at a time. So moving on to relative moves and docking. When the robot makes a relative move, either in a mission action, a docking action, or when undocking, it'll now make a full plan for how to move to the goal position relative to its current position. And then the robot still travels in a straight line towards that goal and stops for obstacles along the way. And provided collision detection is enabled while that's happening, but the robot can handle obstacles and other expected events better now that it makes a path to follow as we do that docking and undocking. So it's recommended on older applications that are upgraded to software 3 to not enable this setting. If you wish to use the new docking method, all docking and calibrations should be tested and evaluated. But new settings or new applications should not enable this setting unless that's something you are having issues with. So after performance improvements, we'll go into upgrade process, give you an idea and a taste of what an upgrade process would look like as you go from version 2 to version 3. So there is a software update guide. So this guide can be found in MiR support portal. We also have it in our handouts as well. So if that's something you're interested in, you could download that straight from the handouts through this webinar. This guide breaks down the robot upgrade process into step-by-step actions, making the update very straightforward if followed to a T. So Hartfiel is also willing to assist you with these upgrades as you see fit. If you're having issues or questions, or you have a specific question about an application, feel free to reach out to us. I do want to mention that as you upgrade from 2 to 3, you do want to be on the latest version of 2 in order to go to 3. So with this upgrade, MiR Fleet has also been upgraded as well. Now you can have Fleet on version 3 as well. So there's a guide for Fleet, and it's in the same handout. But you can hand that over to your IT team and give them a little bit of insight as to what the upgrade will look like prior to the day of the upgrade, because you do need both Fleet and your robot to be on the same version. So MiR Fleet and robot versions must match to work properly. So be aware of this prior to updating and make sure to inform your IT team and get everybody on the same page prior to that update. I do want to mention the PC version is now updated in the same procedure as a server solution. So there is the server solution and the PC solution. Previously, the PC solution had different steps to upgrade that to when you did a software upgrade, but now that upgrade looks the same. So MiR does not recommend rolling back to V2 after updating to V3. If you happen to find yourself in this situation, please reach out to either us or MiR directly, and we can open a ticket for you as well, and we can get you the support you need. So if you have any questions, please reach out to our support team. That email down there, support@hartfield.zendesk.com. We'll get you over our support team, and we can assist you accordingly. So after upgrade process, that's kind of what that looks like. We'll go into some of the risks that we've analyzed and think you guys should be aware of. So one thing we want to make sure you guys are doing is that you're reviewing and verifying all your robot settings are correct and migrated properly. So this means taking note of what you have changed prior to upgrading. That way you can ensure that after post-upgrade that those settings are still valid and accurate. And then after that, you'll want to double check all your missions and verify all those missions are functioning properly. You wouldn't want to just upgrade and then go, all right, send everything back out to the floor. You would want to double check all those missions just to make sure any issues are resolved in a timely manner. So as I mentioned previously, you'll want to update those access zones. So since you do lose those critical zones, they're replaced by those access zones and they function a little bit differently. So you'll want to double check and make sure any areas where you have those doors that would open that you would encounter, or slight slopes or ramps, make sure that those are marked as access zones. The blocked path timeout, as I mentioned, you'll need to configure that in your missions if you do want to use that setting. We recommend setting this up as a variable in a base mission and then pulling that into a parent mission so you can easily adjust that wherever you need it without having to go into every single mission and change that setting. So you'll want to also ensure those directional zones as well are changing. So any of those settings, if you do want to use that directional zone where you can drive against directional zones, make sure that setting is checked or unchecked based on your preferences. The next thing would be the UTC timestamp changes. So some of the changes in this UTC timestamp include user authentication, missions, and paths. So when you do queue those missions, they used to run off the UTC, just general UTC, and now it's local to wherever you live or have this system implemented. So any missions that you scheduled before the upgrade will not run at an expected time. So you'll want to make sure that queue is clear and you're ready to upgrade prior to upgrading. And the last one, and this is pretty important for custom applications. So the API calls have been changed and updated in some cases. So you'll want to verify the calls that you're using are still accurate in this new version as well. And I have included a handout for that, but if you do need a specific robot or you have some questions on that, that's available on the MiR support page, or you can reach out to our support team and we can send that file over to you as well. It is a heavy document, it's around 400 pages, so just keep that in mind. But if you know which API calls you're using, you can use the search function and find those pretty easily and just double check, make sure they're the same. So in the event you do notice an issue, please reach out to us and we can recommend a best course of action and help you resolve any issues you might be seeing on that side. So now I'll turn this over to Liam and he can go through insights.
Thanks, Kyle. So now we will walk through MiR Insights. We'll really just kind of give an overview on what it is, how it works, and really what the benefits of using it are. So what is MiR Insights? MiR Insights is an analytics tool that we at MiR have built to allow users to view the overall performance of their robot fleet. Behind the scenes, what Insights is essentially a database that is collecting data directly from the MiR fleet and has a user interface allowing end users to then visualize that data. The data itself is a way to really see precise and actionable insights about the robot in real time. And really the benefits of having this tool are that it can help improve the fleet's overall performance, increase the robot uptime, troubleshoot more efficiently and quickly, and overall just increase ROI on the fleet. One important note here is that MiR Insights is available with both version 2, our older version of software, as well as version 3 that Kyle just went over, the new version of software. So how Insights is working behind the scenes is that it is a cloud-based solution that's actually receiving data directly from MiR fleet via an internet connection. A MiR Insights agent is installed on the same hardware as fleet, and that sends data directly to the cloud. Because it connects directly to fleet and not to the individual robots, it doesn't interfere with the existing robot installation in any way. And that data, that new data that's sent to the fleet, is refreshed every 5 minutes to show new data that's been imported to the system. So on the next slide here, we'll start to go over some of the main features of Insights itself. So there's really two main components to Insights. One are performance metrics and the other are heat maps. The first one we'll kind of review are the performance metrics. So these metrics are essentially the key KPIs like distance driven, robot utilization and uptime, number of missions completed, and mission completion rate. These KPIs really give you the overall efficiency of how the fleet is running. Are we getting the most out of the existing robots that we have? You can filter these metrics over time and see how the utilization of the fleet is increased or decreased. A specific example of why you might do this is that you can tell if robots are more efficient during a certain shift or day of the week. This can be helpful if you see kind of an ebb and flow in how the robots are being used to see if there's actually a difference in how they're performing overall. The other part that this enables is actually increased troubleshooting as well. So using the performance metrics, you can see the number of e-stops, errors, and manual interventions that have actually occurred. So this can show you not just that robots are stopped, but also more so why the robots are actually stopped at that time. The next,
about that, Liam. Let me grab the correct slide here. Off on heat maps.
Thanks,
Get you over
Kyle.
to Wi-Fi. Sorry about that.
So yeah, if you can just go back one slide, Kyle, we'll touch on the heat maps. Perfect. So the second major component to maps allow you to actually visualize different metrics across the physical environment that the robots are operating in. So you can see from the picture in the left here that it actually uses the live or real layout of the facility that you're operating in. So you can see what issues are actually happening where within the facility. Using this data, you can pretty easily determine where the fleet is losing efficiency due to poor connectivity, or for example, where robots are being e-stopped or being delayed along their route. In high traffic areas, you can see where the robots have to wait because one, they are either being e-stopped. Usually robots are e-stopped when there's a lot of human foot traffic or maybe fork truck traffic, but you can also see where robots are often in close proximity to each other. So one of the things that you can enable through Fleet is essentially traffic management. By seeing where robots are stopped near each other, you can improve your layout to increase the overall efficiency. The robot heat maps can also show the localization score. So this basically helps determine where the map quality is poor in certain areas. So the kind of obvious outcomes from this are that either the map is not accurate in that area, or that there's not enough static objects for the robot to confidently navigate. So this can help you improve the overall performance by either adding features in that area or potentially redoing the map in that area. So the next thing we will walk through are a couple specific use cases of where we can see the benefits. So the first one here is in the case that we believe we have poor Wi-Fi coverage. So this might be indicated by the fact that robots are not being sent new missions in a specific area, or are not interacting with some other piece of automation in the way we would expect within a certain area in the map. The hypothesis here is that it could either be potentially a network issue or a hardware issue on one or more of the robots itself. So there's a number of ways you can filter against the data. So in this case, we would use the signal strength heat map in MiR Insights to see what the issue might be. In that heat map, likely the first thing we would do is filter the data by average, minimum, and maximum signal strength in that area. This would indicate to us whether this is an issue that's happening constantly or is something that only happens sporadically as we're driving throughout that area. If it is something that's constant, we might assume in that case that potentially we would need a new access point in that area to improve connection. If not, we might dive a little deeper into what the actual issue is. So in that case, we might filter the data by specific robots. By filtering across the robots, we can see if this issue is isolated to just a single robot or potentially a group of robots. In that case, that would indicate to us that potentially there's a hardware issue that would need to be resolved. On the next slide, we'll dive into the next scenario. So the next scenario here is that we observe that in certain areas of the map, robots are seemingly moving very slowly throughout a specific area. This could be because they're being e-stopped or, again, frequently have to navigate around each other. The first place we might start is using the robot intersection heat map to view where robots are in close proximity to each other. Once we pull up that heat map, we can actually view, by hovering over specific areas on the map, exactly how long the robots spend paused in each of those areas to understand the exact delay that those are causing to our mission efficiency. If the missions appear to be caused and paused by e-stops, we consider adding a dedicated AMR travel lane in that specific area to potentially avoid conflicts between human foot traffic, fork truck traffic, and the robots themselves. If the issue is being caused instead by robots being in close proximity to each other for an extended period of time, we might add a directional zone or a one machine zone in that area to prevent robot slowdowns. The other advantage of the heat maps as well is that once a fix has been implemented, we can actually filter out old data to ensure that the change we made is having a positive impact. There's a number of other scenarios that might be applicable for using this data. For example, if expected mission times are slower than what we would anticipate, or if mission completion percentage is too low, we can use either the performance data or the heat map data to dive into those as well. So on the next slide here, we will dive into the two different versions of Insights that we have available. So it's really available in two forms. The first is called MiR Insights Basic, and the other is MiR Insights Pro. Essentially, the Pro version is going to be a more feature-rich version of MiR Insights. Both of these versions can be made available by participating in our robot service level agreements. So we have a 4-tier robot service plan. The MiR Insights Basic is available through the standard level SLA, and the MiR Insights Pro can be available through the Plus and Premium SLAs. Both the Pro and Basic can also be optioned as a standalone service item as well. The features that are included in the Basic MiR Insights are live operations dashboards, access to heat maps from uploaded robot logs, and access to the raw data itself so that you can kind of dive into those specific metrics and find the metrics that are important to you. The Pro MiR Insights has access to all the features available with Basic, with the addition of live advanced mission dashboards, live heat maps for connectivity, live dashboards for robot performance, and access to 6 months of data versus the 3 months for MiR Basic. In addition to those features, we have a dedicated development team constantly working on the MiR Insights product and making new features and additions available to our customers. So with that wraps up everything we wanted to cover, both with software version 3 as well as MiR Insights. So at this point, Lisa or Kyle, I'm not sure if we have time for a little Q&A here.
Yeah, we'll kick it over to a Q&A and see if anyone has any questions and see if we can get those answered. Looks like someone has a question on how long is the initial installation process. So in the transition from, if you go straight from version 2.14.7 to 3.3 would be the current version. Typically it takes around a half hour to get one robot from that portion upgraded to 3.3. So there's some files you got to download, and then I always like to make sure I'm prepared. So I would say around a half hour. It definitely gets, the first one might take you 40 minutes. And then, you know, as you do it, if you have multiple robots, it gets a little bit faster. So hope that answers your question. Oh, okay. The initial scan of the factory and the initial installation of, say, one robot. So it depends how big your facility is and how many dynamic objects you have in that facility. So when you do make a new map, you want to make sure that any moving objects such as carts or, you know, things that you have around the facility that aren't always in a consistent position, you want to clean up that map and make sure that you only have solid objects on that map that don't move. So it honestly kind of depends on the application. So I would say you could probably do that in around a week's time. but it does depend on the size of the facility. So we got another question here. I noticed that in version 3, footprint could only be set at a minimum. Same on the smallest field set. How will it affect the robot navigation in a narrow aisle? So the minimum footprint of the robot is going to be the footprint of the actual existing robot. So if you go any smaller than the robot itself, you risk running into things. So we always recommend not to go smaller than that. But as you navigate those dynamic aisles, you definitely want to make sure that you're following space constraint guidelines. So it kind of depends on the width of the aisle and the size of the robot that you're talking about. But for the most part, I've been able to navigate narrow aisles just as well, and honestly a little bit better, just due to the updated planner settings. The robot plans much better down those narrower aisles, as well as just throughout the facility in general. Looks like that might be it for questions. Go one more minute and see if anyone has another question. Otherwise, wrap things up here. All right, well, I think that's it. Thank you for joining. Appreciate your guys' time. Again, if you have any questions, reach out. One more question. So version 3.3 is included in all of this, but version 3.4 has been changed over to a subscription plan. So MiR has been looking at that for a while. I don't know, Liam, if you could speak to that a little bit, what the thought process behind that was, or the, kind of the change, I guess.
Sure. So yeah, one important distinction there, Kyle, is that the software itself is still available with the robot when it's delivered. The change here is that there is a service item, basically a software upgrade subscription, in order to upgrade to any new versions of software past version 3.3 that are available. So again, the software itself still comes with the robot and does not require a monthly or annual subscription, but essentially that is for the ability to upgrade to newer versions of software. The exceptions to that, one, if there's a technical issue identified with an older version of software, a newer version can be made available. The other exception is that if a new robot on a newer version of software is added to an existing fleet, all the other robots in that fleet would then be able to be upgraded to that latest version.
Awesome. Thank you. Looks like someone has a question. When you select a variable for a position and that position is used for more than one move, can you make the selected position default for the rest of the variables without asking the operator to select the same position multiple times? if I think I understand your question correctly, so when you structure those missions, you can set those as, you can set a default position or selection. The operator shouldn't have to interact with those missions unless they're the ones creating the missions themselves. But you can set defaults with those variables as you structure those missions. All right, well, I think that's going to conclude our short webinar. Thank you. Thanks again for joining. Again, if you have any questions, feel free to reach out to us. Answer any questions you guys have.